My Lab 3 black hole presentation video. Sorry, this is not working. Oh, there we go. Okay, so for a bit of an introduction, my task was to determine a computational model to measure the mass of a black hole. And to do this, I altered the starter code in GlowScript to represent the motion and mass of the black hole. And so some main principles used were Newton's second law, the momentum principle, circular motion being the parallel and perpendicular components, and gravitational forces. So not only did these help in conceptualizing what was happening, but also it helped alter the code in GlowScript. And so the programs used were GlowScript and Excel. Excel was used to calculate the average mass. So for my code, the code ended up calculating dp/dt, the change in momentum over time, the distance from the star to the black hole, and the corresponding mass of the black hole. So I have just attached the part of the code that we were allowed to change. And so I made my initializations and I changed the code here and here and here. Yeah, so that's how it worked. So my simulation and results resulted in a relatively circular path, and each simulation outputted a mass of the black hole. There were about 450. It was tedious indeed. And so I calculated the average mass, which came out to be 2.0961 times 10 to the 34th. So in conclusion, that's not supposed to be there. One sec. Really good stuff. In conclusion, to answer some of my analysis questions. So the first question was about net force. So if the overall, it's comparing the net force and the rate and change of momentum and their corresponding parallel and perpendicular components. So I said the overall net force is equal to the rate of change of momentum, which equals the perpendicular component of the rate of change of momentum added to the parallel component of the rate of change of momentum. Oftentimes when calculating these parallel and perpendicular components, we assign new axes, the n hat and p hat axes. This is different from net force and its parallel and perpendicular components because they are based on the xy axes. And to answer the second what if question, if the black hole was removed and a different one was placed in the same location, the star's motion can be measured, but the gravitational force cannot. The changes in speed and direction of the star's motion are associated to the changes in momentum, which tell you which forces are involved. So if the motion is the same, then the forces will also appear to be the same, and therefore the changes in mass would not be detected. Thank you for listening. Sorry it was a little bit silly, but yeah.